So, how was the previous test? And I know you just took this last test. So tell me, how did that go?
The most recent one.
The most recent one, yeah.
Yes. Okay. So the most recent one, I got a 93. I only
Okay.
missed two. So that's awesome. And the
Very
one before
nice.
that, I got a 98.5. So it's amazing. I never thought I could do this. So I was freaking out on the last
Yeah.
one. And then I managed to get another A. So I'm so happy.
So this probably brings you up to an A, right, in the class?
I haven't checked what it is right now. It should definitely be an A because I had an
Yeah.
89 point something before. So with this, it'll definitely be an A now.
So you
Yeah.
have an A. Okay, dude, I'm so proud. I'm so proud. You've gotten two
Thank
A's
you.
like back to back. Ah, love it. Okay, cool. Then
Yeah. Come a long way.
Yes, you have. You've come a very long way. This next topic is going to be pretty simple, I'd say, compared to everything else that we've been doing. So there are several different types of chemical reactions. The main ones that we're going to cover are these 6, but overall in the class, you're going to see a lot more. Like we'll later talk about redox reactions, net ionic. I'm throwing these out there now, but eventually, it'll make sense. But for now, in this specific section, you typically just look at these main ones. So I'm going to just start off with the different types. So the first type is synthesis, also known as combination. So it's going to be important to be able to identify the type of reaction because they might give you an example. Like let's say if they gave you something like this and they were to ask, oh, what type of, identify the type of chemical reaction. But just by looking at it, you have to know, oh, this is a synthesis reaction. How you can tell with that is simply this. So if I were to look at, let's say, I want you to think of actually synthesis and combination. It's kind of in the name where you're combining two things together to form your final product. So in this case, it's really simple, just showing, okay, A plus B gives us that compound, right? Gives us A and B together. So that's essentially what synthesis is. And you'll see that with this example, we're simply combining carbon and oxygen, and then that's becoming carbon dioxide. That's really it. The next one is the opposite. So decomposition is actually breaking things apart. And if you notice, the example has completely flipped around, where now we're starting with this compound and we're breaking it apart into its separate elements. So that's why we're separating this from A to B. So they're not all going to be this easy. Of course, we know that with chemistry. So instead, I want you to kind of just think of this as synthesis basically has more reactants, and then it combines our reactants to form our product, or a smaller amount of products, right? And then decomposition is the opposite. We're going to break something that's larger, a compound, down into its single elements. So that's kind of a clue for you. And we see that here with the example of carbon dioxide. We're going to separate this into its elements, so carbon and oxygen. Next is single replacement. It's also referred to as single displacement. I typically have always heard it as replacement, but either one works. And now this is introducing something a little bit different, where now we have, let's say, this element on its own, and then we have a compound. So I kind of like to think of this as it's one element plus one compound. And it's like we're switching things around. If you notice, A and B now combine to form our product, or the other compound. And then now C is left by itself. So one element. So that would be single replacement, single displacement. And we see that here with the example, magnesium is now going to take the place of hydrogen, and magnesium combines with the chlorine to form our compound, and now hydrogen is left on its own. So it doesn't always have to be C, it could continually just keep changing.
Okay, but whenever there's a number in front of them, it applies to both. So the 2 in front of the HCl, that means there's 2 hydrogens and 2 chlorides?
Yes, chlorines, yeah.
Okay,
and it's just to balance things out. Yeah, and we will talk about balancing equations. We'll practice that today. Next one is double replacement or double displacement. And this is really similar to the last one, except now we're pretty basically having a bunch of compounds, and then we're swapping them to form 2 new compounds. So in this case, I see this is A and B. Now the A will combine with D, and then B and C combine to form the next product or compound. So it's kind of like everything is switching around. That's why it's replacement, right? We're replacing those elements to then form new compounds, which we'll see that here, like magnesium and nitrate are going to combine to form our first product, and then barium and sulfate will combine to form our second product. Any questions so far?
No, this seems doable. I mean, it's a little confusing, like once you start mixing so many different ones up,
Yes.
but...
Right. Well, you'll be able to see the clues once we kind of like have to identify all of them, and I'll help you go through it. Combustion, I would say, is the easiest one to spot because the main thing that never changes is this. So you're always going to have O2 as your reactant, and you're always going to have your product being carbon dioxide and water. That never changes for combustion. So that's the easiest way to be able to spot, oh, this is combustion for sure. The thing that will be changing each time is going to be this first part. So this is known as a hydrocarbon. Hydrocarbon just really means that it only consists of hydrogen and carbon. So in this case, we could have seen like, oh, this example, CH4. But if I see that everything here has that O2 and carbon dioxide and water, I know that that's immediately combustion. Another type of combustion reaction that we can see is this part where now we have oxygen. So it's not only carbon and hydrogen, it's also carbon, hydrogen, and oxygen. But once again, this is going to tell you that, oh, this is combustion because I have everything. I have O2, CO2, and H2O. Makes sense.
Okay.
Next one. So acid-base neutralization, this is our last one. Well, you're always going to start off with an acid. How you know something is an acid is it's going to start with a hydrogen. So in this case, for our example, we'll see, okay, well, yeah, this has to be my acid because it starts with a hydrogen. And then next, I see, well, okay, what about my base? Well, my base has to end. So acid has to start with a hydrogen, base has to end in OH. And we're going to see that here too, where, yep, this has to be my base because it ends, I'm going to just show that it ends in OH. So that's our base. So for acid plus a base, that's going to give us salt. So that produces salt. And we know something is a salt if it is an ionic compound. We know something is ionic if it consists of one metal and one non-metal. So I know that for sure this had to have been my salt because this is a metal, right? That Na is a metal and Cl is my non-metal. That is an ionic compound. And then of course, water, H2O. So that's pretty much it with that. So that's how you could easily tell like, oh, this is an acid-base neutralization reaction because I see it has an acid or a base. Something to note is that it's not always going to be in this order. So it could have started off with the base plus the acid to then form, let's say, the salt or water and salt.
Okay.
Yeah, the order does not matter since everything, like we're adding everything up. What matters is basically what side everything's on. And even then this still would have been different. I doubt you're going to see like water and salt, like I'm saying this. I doubt you're going to see that this is salt plus water gives you acid plus base. I don't think they're going to do to that extent. I just think they're going to switch things up in the reactant side and the product side. And just to make sure we know that the left side are called the reactants and the right side are the products. Just to know that because I'm going to keep referring to that. All right. And practice. So what I want you to do is I sent you these practice problems. So I want you to try to figure out what type of reaction each one is.
All right, here we go. So this first one has this plus this. I think this is this double replacement?
Good. Yeah, it is. Perfect. Because
Really?
we have,
Oh my gosh.
yeah, that's right. So we have two compounds and that are basically kind of like swapping with each other to form two new compounds. So that's double replacement. Yeah.
That was the hard one, so in my opinion. Okay. So now we have NO2 and O2. It's just like so weird to look at things like this because this is my first time ever looking at like, what is this? Right. I just see letters and numbers everywhere.
So just describe what's happening. Like for 2, we're starting off with something, right? NO2 plus O2. And what's happening?
Then the two of them, see, I don't know because it seems like we're getting rid of something. Oh, no, wait, I honestly don't know because I see the N and the O coming together, but the numbers aren't matching up.
Exactly, and that's okay. And it's okay that the numbers aren't matching up. So I just want you to look at the elements. So you just said they're coming together or they're combining, right? So we have two elements. Exactly. 2 elements that are now combining. So don't worry too much about the numbers right now. We haven't covered balancing. I just want you to pay attention to where the elements are going.
Oh, I see. Okay. All right. So this next one is going from aluminum to...
Oh, one thing. Can you just write on the side what you found for everything?
Yeah. Okay.
Cool.
So... Okay.
So what's happening?
I just am trying to remember because I see that they're just flipping on the other side.
Okay.
And and the oxygen's going with the aluminum too. Okay. Is it single replacement?
Yes. Perfect. Exactly.
Well,
yes, it is. So think of it like you're saying they're flipping or they're replacing with each other, right? So it's single because only one element is doing that. Versus the first one, number 1, it's double replacement because, well, 2 of them are swapping, right? Like 2 of them are being replaced. So that's kind of an easier way to look at it. This next one, let's try this next one.
What the heck?
I know. So I want you to think of, I don't want you to think of double replacement. This one's trickier. So instead, I want you to look back and see, well, I said that acid-base, I know I just gave it away, but acid-base neutralization starts with an acid or has an acid at least as a reactant. And I know an acid starts with an H. Do we have that?
Yes, right here.
Cool. So we can label that as our acid. So, okay, I know that's a type of acid. Perfect. I know a base has to be on the reactant side as well, and a base ends in OH. Do we have that?
Okay, yes.
Yeah, I know you see it already. But now to just confirm, now looking on the product side or the right side, we see, okay, well, I need something that's a salt. So a type of salt would be anything that's an ionic compound. Do we have an ionic compound? Exactly. Yes, we do. And then we have water.
Yes.
So you see how they're switching it up. It's not always going to be base. It's not always going to be acid plus base. Yeah, they're trying to confuse you, unfortunately. But
okay, yeah, I feel like I definitely would have noticed it easier if it would have been the other way.
Exactly. Yeah.
Okay, so I'll look out for that.
Yeah. But this one we know is acid base neutralization. So you can just put acid base.
Okay.
Good. What about this next one?
I'm trying to look at what I have left.
What you have left?
What? Like which ones I haven't done yet? What do you mean?
No. I know. You're strategic there. It's a good strategy.
Well, at least I know I can't beat it.
You know how I test you already.
Yeah. Okay. I'm trying to remember like what the things mean. I know that combustion was the one you said you can always spot this one because...
Yes.
But what was it?
So it's that one. The way that you can spot the way that you can spot combustion is there's always going to be an O2 on the reactant side, and then the products will always be CO2 and H2O. Yep.
Okay, so that's what we're looking at. All right.
Correct. And it has to give all three. So that has to be everything. Like, has to have O2, has to have CO2 and H2O in those locations for it to be combustion, or else it's not.
So could it have more on the other side as long as it did still have the CO2 and the H2O? Or does that not really happen?
It doesn't really happen, no. Not that you're going to see, so I wouldn't say to worry about that. It's like, I've only seen it as, at least for this class, I've only seen it as like this. Like, it's always going to be O2 on the reactant side, and then the products will always be CO2 and water.
Got it, okay. And then this one, we have a C and H and O, and then the C plus H2O. I know technically it should be decomposition.
But why?
Because that's the only one left, but I'm trying to figure out why. Because we're breaking down the H and the O. Because to me, I feel like we're like bringing them together. So.
But we're at least separating this, right? So we started off with one thing, and now we're separating it down to two separate things.
Oh, I see. Okay, so even though they're next to each other, they're not. Or when they're next to each other, they are connected. And then when we put the plus, they're separating it.
Correct. Yeah.
Okay. Cool.
Yeah, so that's going to be the easier way to spot, like, synthesis. I have two separate things, and I'm bringing one together. Or you might have multiple. You might have, like, three separate things, and you're, like, reducing the amount of products. You get what I mean? And then it's the opposite for decomposition. We're going to start off either with one thing, and then separating that into several things. That's very scientific, but yeah. But yeah, to make it easier. Cool. So yeah, that was all correct. Any questions with this?
No, this makes sense. I'll just need to practice it and try to like remember the little rules that you told me, but yeah.
Cool. If you're enjoying this series so far, make sure to give this video a like and let me know in the comments how you're currently doing in chemistry.